Chapter 9, Chemical Bonding, the Lewis model. So we're going to look at three different models for chemical bonding. And models are, these are theories explaining how atoms bond together to form molecules. It's not a law that says this is what happens, but we're trying to explain. Some of the things we're trying to explain are why are some molecules stable and others are not. Okay, atoms are not like Lego blocks where you can just put them together in any combination you want. You can, H2O is stable, but if you want HO2, it's not stable. Why not? Well, these bonding theories explain that. Bonding theories also help us to understand the shapes of molecules and allow us to predict the shapes. And the shape of the molecule has a big effect on the chemical and physical properties, which, those are really important. So these three different models are useful for different reasons. There's a trade-off between predictive power and complexity. So if you want great predictive power, you're also going to get great complexity. Okay? Complexity means it's harder to understand, it's harder to use. And so we're going to start with the simplest one. And it doesn't work for everything, but it works for some stuff. And it's not so hard to understand. So how could all this bonding stuff be useful? Well, in 1989, the structure of HIV protease was determined. That's a protein that's synthesized by HIV and is important in the reproduction and the infection of HIV. So researchers, trying to find a cure for HIV or even just something to slow it down so people could have a longer, better life. So they designed several molecules that disable HIV protease by binding to the active site. It's an enzyme. And so how do you do that? Well, do you just try random stuff? Well, you could, but that's going to take a long time, and research is expensive. So what they did is, now that they knew the structure of it, they look at the structure of the active site, and they're looking for molecules that will bind in there and compete with the natural substrate for the protease. And so that makes your research much more efficient. And they were able to find several potential drug molecules and look at how they would interact with the protease. And so they did come up with some that are pretty effective. They don't cure HIV, but they reduce viral levels down to where you can't even detect them. So as long as you keep taking the protease inhibitor, it suppresses the HIV infection in person. Now, today, if you're HIV positive, you can actually live a pretty normal life with a normal lifespan because of these drugs. And bonding models had a big part to do in developing those. So the Lewis model is the first one we're going to talk about, and this is the simplest one, but also the most limited. This one's named after an American chemist. And in the Lewis model, we represent valence electrons as dots. So these are often called Lewis dot structures or electron dot structures or Lewis electron dot structures. I'll probably end up using all the possible combinations. So we draw molecules using dots. It's the simplest. It helps us predict the shapes of many molecules, and it helps us to understand if a molecule is likely to be stable or not.